This is Paul again from the Lind and Wilson groups at the University of Texas at Austin, with another video explaining some more basics in polymer science. This time I'd like to cover a special polymer that has found several applications in industry, named polysodium acrylate, and has the structural formula shown here. Because you likely don't have a background in organic chemistry, I'd also like to introduce what these lines and letters in our chemical structure here actually mean. To make things a bit easier, I'm going to make a molecule that represents our polysodium acrylate in a clearer format. First off, the letters and abbreviations represent different atoms that are found in the molecule. Here, O stands for oxygen and Na stands for sodium, just like they're found on the periodic table. These abbreviations are strange sometimes because they often come from Greek or Latin languages. So what are these lines and angles between atoms? The lines, a few of which are shown here, are actually chemical bonds between different atoms. Bonds can be described as the two atoms sharing electrons so that they can be lower in energy. You'll notice that some of these bonds also have an angle to them. The point where the lines meet in each angle actually represents a carbon atom, highlighted in red. As you've probably heard, carbon is an extremely important element and is used in building a wide variety of molecules. Now, each carbon atom loves to have four bonds between itself and other atoms, whether it be another carbon atom or an oxygen, nitrogen, and many other elements. In fact, carbon can turn rather violent if it's forced to only have 3 or 5 bonds. Many of you have probably already noticed that we don't have 4 bonds connected to all the carbon atoms right now, because we don't have 4 lines coming off of each carbon atom. That's because there are implied hydrogen atoms spanning off of all the carbon atoms that don't already have 4 bonds. The true structure looks something like this. Note that a few of our oxygens share 2 bonds with the neighboring carbon. So why are we drawing structures the way we do? Why not explicitly write out all the carbons and hydrogens? Well, anyone who's taken organic chemistry knows that you would have to write thousands upon thousands of carbon and hydrogens during one semester of chemistry. Not only that, but when you're scribbling down to write a structure that a professor mentioned, it's so much faster to draw lines and angles than write the letters C and H over and over again. Not only that, but our structure remains less cluttered whenever we're drawing these lines and angles rather than explicit carbons and hydrogens. I should also mention the pluses and minuses shown here. The sodium, again shown as Na, has a positive charge, while the oxygen has a negative charge. We know from physics that opposite charges attract, so these ions are often found near one another and helps give polysodium acrylate its properties. Moving on, we had brackets in our original structure. Now in polymer science, it's very tedious to write out the repeat units on a polymer over and over again, because sometimes you'll have 100, 1,000, 1,000,000 or more repeat units. You don't want to draw all of those out. So to make things easier, we draw a repeat unit and surround it by brackets, telling others that this thing repeats itself so many times, as indicated by the letter N in the bottom right of the right bracket. If N equals 100, then we have 100 repeat units, or what's shown in the bracket repeats itself 100 times. We also have the end groups of the polymer, shown here, which represent what's on the end of the polymer chain. If we don't know or don't care, then we usually draw a star, and because I don't care, I drew a star on both ends of my polymer. Polysodium acrylate is able to absorb such a large amount of liquid by the way that the polymer chain interacts with the water. While dry, the polymer bunches up due to interactions between the negative charges on the oxygen and positive charges on the sodium atoms, as well as a gain in entropy, which we won't talk about. However, when introducing water, the hydrogens in the water molecule compete with and dissolve the sodium ions, allowing the polymer chain to begin to unravel and get our fake snow. Here in Austin, Texas, we appreciate this application a little bit more, as the weather has been around 70 degrees Fahrenheit all throughout this November. So we can pretend to experience snow with this compound when the likelihood of any natural frozen precipitation occurring is pretty low. Polysodium acrylate has another useful application that many of the adults in the room will appreciate: diapers. This polymer is the main ingredient to soak up any of the kidney filtrate and other liquids you might find being produced by babies that you'd really rather stay in a diaper than be elsewhere. In the next part of the video, I'll be showing a quick demonstration of some of these properties. I hope this video has been an educational experience for all those. Hey there, it's Paul Meyer again. Now I'm going to give you a live demonstration of some of the properties of polysodium acrylate, also known as sodium polyacrylate. So I went ahead and bought some of the polymer off of the internet here, and I'm going to go ahead and do a first demonstration where I spray it with water just to show you the high mass uptake. Then I'm going to take a squirt bottle of water. You can see it says H2O right there. I'm going to squirt water all in the polymer. I'm going to mix it around with my finger a little bit. Zoom up close so you can see it. So the important thing here, you can see it's absorbed all the water. There's no water dripping out onto my hand right now. So all of the polymer has absorbed it and it's stuck inside of the polymer. I hope this video has been an educational experience for all those who've watched it. The purpose of these videos is to teach middle school and high school level students some basics of polymer science and some of the neat applications. Please feel free to distribute this video to any teachers or educators